All right, so today what we're going to be going over is we're going to be going over as many questions out of the system of inequalities test that students had to take. So we're going to be going over these. So what I want you to do right now is simply make a beautiful x-axis and y-axis on your paper. That's all I need you to do. All right, so we're drawing an x-axis and a y-axis, just like that. If you would please go ahead and label this your x, label that your y. We're going to take a look at the problem real quick. So one of them right now, I want you guys to write y is greater than or equal to x, let me look real quick, plus 4. All right, and the other one I want you to do y is greater than negative x minus 1. So these are the two I'd like you to put into your journal. We're going to talk about how to interpret this, okay? Now, this right here, this symbol tells me two things about what I need to do with the graph. Because of the equal sign, I know the graph's going to be solid. And because of the greater than, I know it's going to be shaded above. So I'm going to put shade above. All right? Over here, that inequality sign, being that it's greater than, tells me two things. One, we're going to have a dashed or a dotted line. I'll just put dotted. And it's also going to be shaded above. So I'm going to put shade above. Now these are both in y equals form. So it gives us a slope and it gives us a y-intercept for both. So put m equals slope just as a review, and put b equals your y-intercept. All right, I'll put m over here. M equals slope, and b equals your y-intercept. And I'll do a better job of spelling slope. All right. Okay. So this tells me what my graphs are going to look like. This says y is greater than or equal to x plus 4. Does anybody want to guess what the slope is of this? Go ahead. Correct. 1 over 1, or just 1. So we have a slope of 1, which means if we're plotting it, we're going to do 1 over 1, which means we're going to go up 1 and over 1 to the right. What about the y-intercept? Where's our y-intercept going to be? Looking at this. 4. Very good. Y-intercept's at a 4. So let's go ahead and plot that line. 1, 2, 3, 4. All right. Take a look. All right. Yep. Okay. And so we're going to go up 1 and over 1. Well, we're kind of running out of room, but we can also go down 1 and over 1 to the left. So go ahead and plot those points, just like that. Now, I said it's going to be a solid line, so we got to make sure that we do what? We have to graph something that is solid going through all of those points as best as you can. So make a nice solid line going through those points. All right. The next thing we're going to do, is we're going to look at this slope. What's the slope of our red inequality? Our slope is -1, which means it's going to go what? -1 over 1, which means we're going to go down 1 and over 1 to the right. But our y-intercept's at a -1. So here we go. Put it right there. Going to go down 1 and over 1 to the right, down 1 over 1 to the right, down 1 over 1 to the right. But you can see I could also do up 1 and over 1 to the left if I wanted to. But this line is not going to be solid. We have to change it to a dashed or a dotted line. Make sure it goes through all those points. So now we got to figure out where we're shading. Now this one says shade above, and this one says shade above. All right. So if I'm just going to go ahead and just do one. I'm just going to do one shading. If I shaded everything above the blue line, this is where I would shade if you follow along. Okay, I'm not shading right now. I'm just pretending like I'm shading. Okay, that's where I would shade if it was above. If I was going to shade above the red, the red dotted line, that'd be over here. So where would they overlap? They would overlap right in this what? Right in this general area. Okay, that's where the two would overlap. What I need you guys to do is I need you guys to label this right here. Label this as your what? Solution region. This is your solution region. And we need to talk about what actually would be considered a solution and what would not be considered a solution. Okay? So let me tell you something. After you shade this area, I want you to understand this point right here. This point would also be considered a solution. So any point on the line, so any of these points that are on the line is considered to be a solution. But any points on this dotted or dashed line, you guys see this point right here that I just plotted right there? That point is not a solution. I'm going to put not a solution. So any point that's on the dotted line is not considered to be a solution, whereas any point that's on the solid line is considered to be a solution. And any point where? Any point in the solution region. So any point in the solution region is considered to be a solution. All right? Now, this is a great example of how to graph, where you shade, all that stuff. So if we looked at our quote question, okay? If we looked at the question that was given to you, all right? I realize I can't zoom in, okay? But this graph is shaded above, all right? This one's dotted, so that's why it's y is greater than negative x minus 1, and this is y is greater than or equal to x plus 4. So answer number 1 ended up being C in this particular case, all right? All right, now, right now, go ahead and put your pens down, and I want you guys just to focus in on this problem. We're going to take a look at this problem. I know it's kind of hard to see, but we're going to go ahead and take a look at it anyways. This one says which one is what? Not a solution. So let me explain to you what is a solution. Anything that is on this line right here, that would be a solution. Anywhere in this dark shaded region would be a solution, okay? What's not considered to be a solution? Anything on the dotted line, anywhere here, here, or here. So look, 0, -1, which is right there, is that on the dashed line or the dotted line? Yes, so that's not considered to be a solution. That's why that would be the answer, okay? Now 0, 3, check this out. 0, 3 is right there. That's on the solid line, and that's considered to be a part of the solution. So that would be a solution. Right here, check. 6, -2. Well, that's easy, right? That's right. You can clearly see that's a solution. And 4, 0, you can clearly see that's a solution. So what I want you guys to understand is I can actually use this exact same question and just change up the ordered pairs. All right? I might copy or duplicate this problem and say which of the following is a solution. And just make 3 of them not a solution and 1 of them a solution. So I'm letting you guys know ahead of time. You're probably going to see this graph. It'll just have different answer choices. Does it make sense? So solid line, solution, dotted line, not a solution. All right, moving on. Okay, so right now, it's kind of hard to see these right here. So what I'm going to do is I need you guys to draw another graph with me. So we're going to do another graph. All right, so make a nice, beautiful x-axis and a y-axis. And what we're going to do is we're going to do 2 different graphs, okay? One graph, I'm going to put x is greater than or equal to -1. Okay? I'm also going to do another graph, except I'm going to say y is less than -2. So I'm just going to do a couple of examples so we know how to interpret this and how to interpret this. This one's greater than or equal to, this one is just less than. So if you want to label it and say, hey, that's greater or equal, and this one just means less than. All right, here we go. something you need to be aware of. Whenever you guys have an x is greater than or equal to, this will always be what's called a vertical line. All right, so this is going to be what's called a vertical. X equals is always vertical. Y equals is always horizontal. Okay, so a vertical line, you need to make one perfectly at -1. Make a nice vertical line right there, and I'd like you to make sure you label this. That's technically that's x equals -1. Just by itself is x equals -1. Now x is greater than or equal to -1 means technically I have to shade everything that's greater than that. Okay? Now you don't have to do all the shading yet. Okay, you can save that for later if you want, or you can gently shade now if you want to do that. I realize some of you it's really going to annoy you that I wasn't able to get perfectly up to this line right there, so I'm doing my best. It's very difficult, just so you know. All right, there we go. That's about as good as I can do without messing up. Now, the next one, you guys see it says y is less than -2. So I have to make a dotted line, a dashed line. It's got to be at the -2 where y is -2. So you get a horizontal line. And less than means I got to shade below. So everywhere below this has to be shaded. Now can everybody see, as I'm shading it, can everybody see where the solution region would end up? Okay, everybody see the darkest region right there? So everybody, if you want to, you could say, hey, you know what? Right in there, right in this area, right here is what's called the solution region. All right, there's the solution region. Now, what does that mean? Any point that's in this area is a solution. Now, could I put a point on the dotted line right there? No, I can't. But could I put a point on the solid line? Yes. So solid line is a solution. Dotted line is not a solution. I know, right? I know. But this is why we're going over as a review. So when you guys see this on your 6 weeks test, you'll be like, okay, I got this. This is not going to be that big of a deal. Okay? All right. So this is just a couple of graphs. One is what? X equals. One is y equals. X is always vertical. Y is always horizontal. All right. So I know it's going to be kind of hard to see. So hopefully you have that down. It says this one technically, it's kind of hard. You can't even see it. Basically, just so you guys know, this one says which one was x is greater than or equal to -2. Well, equal to means a what? Solid line. So even if you can't even have to get your magnifying glass, can you see this is the only one that has a solid line? All of that's a y is less than. That's x is less than. This is x is less than. This is the only one that x is greater than or equal to. So number 3 was answer choice A. Okay. All right, moving down. All right, you guys probably can see this one. By the way, you don't have to draw this. We'll just do this together. What do we know about this? Automatically, we know what type of line is it. It's it's vertical. So if it's vertical, you know it's always going to be what? X is something, right? So technically, if it was a solid line, it would be x is equal to a -3 if it was a solid. All right, but it's not solid. What's happening? It's shading everywhere to the right. So x is becoming greater than -3. So this is x is greater than -3. If I were to make this solid, or if I colored it in, I made it solid, what would the answer choice be if I made it solid? Yeah, so which answer choice would it be here? D, yes, it would be D, right? If it was solid, but it's not solid, it's dotted, so it's answer choice C. If it was shaded over here, if it was shaded on this side, what would the answer choice be? It'd be A. All right, so if I switch, do you guys know what I'm talking about? If I switched, if all this shading switched over to the left, it would be answer choice A. All right, moving down. Okay, everybody, listen up. I need you guys to put number 5 in your journal. All right, this is going to be super important because there's no graph. I need you guys to write -3, 0. and y is less than or equal to x plus 4, and y is greater than or equal to 2x minus 6. So please put that into your journal. All right, so everybody listen up. What we're going to do right now is I need you guys to label this. This is your x. This is your y. Now I'm going to color code it. I'm going to take -3. I'll make that blue. I'm going to put y is my 0. So wherever there's a y value, we're going to plug in the number 0. Okay? Wherever there's an x value, we're going to plug in a -3. Now it's important that when you plug in numbers, what are we going to use when we're plugging in numbers? Parentheses, except if it's just by itself. You don't have to worry about it if it's just by itself. So if that says 0, just put what? Put a 0, and then put greater than or equal to. If it's just by itself, what number am I going to plug in right there? -3. I'll put plus 4. Right here for the y value, what am I plugging in? 0. All right, I'm going to put greater than or equal to. This is where I use parentheses. If I have a number being multiplied, I always open up a group of parentheses, and what number am I plugging in for x? -3, and put -6. Now let me explain to you. We have to work this out step by step to see if this works. So right now, what do we have left over here? We have a 0, and we're seeing if 0 is less than or equal to -3 plus 4, which is a 1. Is 0 less than or equal to a 1? Yes. So this is what we call a true statement. That's true. Over here, is 0 greater than or equal to 2 times -3 is -6, and -6 minus 6 more is at a -12. Is 0 greater than or equal to -12? Is that a true statement? It is. They are both true statements. Because they are both true statements, I can say, yes, this is considered to be a solution. If I gave you 3 inequalities and gave you an ordered pair, in order for it to be a solution, it would have to meet not just these 2 conditions, it'd have to meet all 3 of them if I gave you one more linear inequality. So in order for it to be a true, in order for it to be a yes, it's got to meet this condition and this condition. If it meets one but not the other, then the answer would have been no. All right, here we go. Now, by the way, I'm not going to make us do this one, okay? But as far as I'm not going to make us like graph all these, I want you guys to write these 2 down though, all right? So could you guys please just write y is less than -x plus 3 and y is greater than x minus 1. Just write those 2 down, okay? So help me out. Let me know when you guys are ready so I can make a nice graph. You guys got them down? Cool. Here we go. Let's make a nice pretty graph. Okay, there we go. I'm gonna do 2 different colors. I'm gonna do red and green. Okay, let's check this out. So one of them was y is less than -x plus 3. So I'm going to put y is less than -x plus 3. And the other one, I'm going to do y is greater than x minus 1. Y is greater than x minus 1. So write those down, nice and neat in your journal. There's your x-axis. There's your y-axis. Okay? All right. Somebody, please tell me my slope and my y-intercept for the red inequality. Good. Now, a -1 slope, what does that mean? That means I'm going down 1 and over 1 to the right. All right, good. This one, what's my slope? Oops, got to change colors to green. There we go. What's my slope on this one, everybody? 1, which means that's a 1 over a 1 slope, which means I go up 1 and over 1 to the right. My y-intercept's at -1. Okay. Whew. Dashed or dotted? Both of them dotted, right? All right, so here we go. Let's go and apply it. So this one's going to be at a y-intercept at 3, and I got to do what? Go down 1 and over 1, down 1, over 1, down 1, over 1, and you got to make a dashed line. So make sure you make yours dashed. I'm just dashing your hopes right now in your dreams. That's not a very good one. Here, I'll try better. I'll do a better job. There we go. There we go. Excellent. Now the other one, it says, where's my y-intercept at a -1? So put it right there, but my slope is +1, so I got to go up 1 over 1, up 1 over 1, up 1 over 1. Why did I want you guys to do this one? Because everything's what? Everything is dotted, correct? And that impacts whether things are a solution. Can anything touch these lines and be a solution? No, you can't touch them, right? Okay. So now we're going to figure out our solution region. So I'm going to go and pause the video real quick. Where are we going to shade on this one? Everywhere below, right? So if I wanted to, I'd shade everywhere below. So right here, this is technically, I'm not doing it, all right? I'm doing a video. That's why I'm kind of showing you. I would shade everything below. What about this one? Where am I going to shade? Everything above. So if everything is below and everything above, does everybody see this region right in here? This is your solution region. So I just want you to shade in just your solution region, which is this area right in here. It just keeps going up forever and ever and ever and ever and ever. Below the red line and above the green line. There we go. That's your solution region. Just remember, a mental note. Make sure you guys put, hey, this is not a solution. I'm just going to put no. No. Right here? Yes. So anywhere in here is considered to be a solution. Anywhere on these lines is not going to be considered a solution. So even especially right here, is that a solution right there? No, because they're both dotted. So even right here, that's where the two lines intersect, but that would be considered no. All right, let's see where we are now. Take a look at this. So what would our answer be for this one? What would you guys say? Which one best matches it? B is correct. You can see that B is the correct answer in this particular case. All right. By the way, we're not going to graph this one. We're not going to graph this one. But why would you not choose A or B when you see these two? What's your biggest clue that A and B are totally wrong? Yes, the vertical line, right? Vertical line is x equals. This is x equals -2. This is x equals negative. Do you guys see x equals -2 anywhere up here? So that lets me know automatically that those aren't going to be the case. All right. So if we were to look at this, how many are these lines going to be dotted or dashed? You're supposed to say neither. They're supposed to be solid. All right. So these are supposed to be what? Solid lines. What's the only answer that has two solid D? That's the only one. And you know these aren't it because those are x equals because they're vertical. Okay. Everybody, put your pencils down. I'm just letting you guys know. This is definitely going to be on the 6 weeks test. I'm just going to switch out the ordered pairs. All right? So right now, how would you guys know? How would you guys describe the solution region? How do you know? I'm going to do 4 different areas here. I'm going to call this area number 1, area number 2, area number 3, and area number 4. So there are 4 different areas. Of those areas, which one would you guys consider to be the solution region? She says 3. What do you say? 3. What do you say? 3. 3. Everybody's choosing 3. Thank goodness, because that's the right region. Okay. Now, how could you tell? Have you guys ever done any art where you guys do like cross hatching? All right. So the darkest region will be the one that's cross hatched the most. It's kind of hard to see, but can you guys see right here that this has one line, this has another, and this is where they cross over. So this is the solution. Yeah, and there's also, can you guys see how much this is the darkest region of them? You can see the color? Okay. So check this out. See 0, 6? 0, 6 is 1, 2, 3, 4, 5, 6 right there. Now, why would that not be a... Yeah, because the top one is dashed. You're right. So that's not a solution. So we have what? -3, 5. So -3, 1, 2, 3, 4, 5 is right there. So that's not a solution. And we have what? 1, 0, which is right there. Why is that a solution? Even though it's not in the region, it's on the solid line. Yeah, so that's why this particular case the answer is C. Then we have what? -3 and +3, which puts us right there. So what did I warn everybody of? I said, you're going to see this. What's the only thing that's going to be different? The ordered pairs. So you got to figure out which one is a solution, which one is it not a solution. Okay? All right. Not going to do this. All right. So it's kind of hard to see, so I'm not really worried about that. But right now, if I'm looking at that, that's it. It looks like there's an equal to sign. So if there's an equal to sign there, even without even doing anything, what answer do you guys think would be if it was an equal to sign? B, right? All right, because all of these are dashed. All right, so okay, this one has an equal to sign. So this is a horizontal line. Which is the only horizontal line that that's an equal to? Yeah, D, right? We can't even see it, and we can still do them. All right. By the way, what boundary is this? Yeah, but is it dotted? Oh, okay, it is dotted. It is dotted. It's dotted and shaded above. What does dotted and shaded above mean? Just greater than. So this is dotted and shaded above, so that would be just greater than. So that would be answer choice C. Take a look at this. I'll scroll all of these right here. Solid or dashed if it says y is less than. Dashed. Shade above or below for y is less than. Below. Shade above or below. Y is greater than or equal to. Above. Solid or dashed. Solid because of the equal to. Okay, here's the last one. I want you guys, we're gonna do in our journals here. Okay? What we're gonna do is I want you guys, don't start doing the graph. Don't start doing the graph. I'll tell you what to graph here. All right? I want you guys to graph y is less than or equal to 2. All right? That's going to be one of them. And then the other one, we're going to do y is greater than, okay, 2x minus 4. So can you guys put that one there in your journal, that one, and we're going to go ahead and graph these. This will be our last graph. Okay? So I'll go to my graph paper. This will be our last one that we do. Make a nice x-axis, y-axis. Make sure you label them, okay? Make it neat so that it can be helpful to you. X, Y. All right. Let me go back and take a look. One of them said what? Y is less than or equal to 2. So I'll do that one in red. So I have y is less than or equal to 2. And then I'll do the other one in green, and I'm going to say y is greater than or equal to, what did I say? Hold on. Oh, no, just greater than, sorry. Not greater than or equal to, just greater than 2x minus 4. Okay? Now what we're going to do, guys, what we're going to do right now is after you write these down, I'm going to show you guys what this would be in standard form. Okay? So right now, what form is this? Slope, intercept form. Okay? We're going to change this. We're going to change this to standard form. So in case you see this exact same problem in standard form. Now standard form, remember, is this. AX plus BY is equal to C. So where the X's and Y's, they're all on the same side. So what would happen if I moved this 2x over to the other side? What would happen? Anybody know? If I took this guy and I'm going to move you across. What would happen? Anybody? If I wanted to grab it, I'm going to grab you right here. Just grab it, throw it across. What would it become? Become a negative. Okay? That's the first thing. Now, by the way, standard form, you're never allowed to have negatives in front of the x. Never allowed to have negatives. So what would I have to do, everybody? I have to multiply everything by a negative. So this would be 2x. That'd be minus y. The inequality sign would go from greater than to less than, and a negative times negative is a positive. So by the way, I'm just letting you guys know, this graph right here in standard form would look like this. Okay? So you know. All right, so what's my slope of this? What's my slope? 2. What's my y-intercept? Yeah, very good. Okay, sliding over. All right, what's my slope? Nope. I'll give you a hint. My y-intercept's 2. What's my slope? 0. Slope 0. So what kind of line am I going to draw right here? I'm going to draw a nice solid line at y equals 2. Where am I going to shade, everybody? Below. I'd shade everything below. Other one. Where's my y-intercept? 1, 2, 3, 4, right here. If I have a slope of 2, that means I have to go up 2 and over 1, up 2 over 1, up 2 over 1. But what kind of line do I have to draw right now? A dash. There we go. Draw a nice dashed line. Where am I shading? Everywhere above it. So if I'm having to do a solution region, and this is everywhere below it, and this is everywhere above it, does everybody see the solution region is going to be right in here? Okay, that's going to be that's the solution region. Now I kind of crossed over there, but there we go. That's your solution region. The reason I wanted you guys to do this one, I want to make sure you guys know a horizontal line is always a y equals. Okay, just like a vertical line is always an x equals. All right, so this is your solution region. All right, let's take a look at the last couple. What would you guys say number 17 is? It's equal to, right? And it's shaded above. Which is the only one that says equal to and shaded above? B, that's less than. C right there. It's greater than or equal to. So that would be the answer for number 17. Where is the solution region? Which one would you definitely have to? It's kind of hard to see. I'm not going to plot all these points, but that's the solution region. All right. Which ordered pair is a solution? Well, obviously, is that point right there the origin? Yeah. So obviously, you could do what? You could choose 0, 0, 0 to be the solution without having to do a whole bunch of work. Now, I'll probably put this one on there as well. Except, what am I going to do? I'm just going to change. I'm going to switch out the ordered pairs, and when it's on your quizzes, you'll be able to zoom in and see that graph. Okay, so that just make sure you're aware of that. All right, and that's it.